Okay, so let me now introduce officially today's quarter series. So for those you who don't know, we did this already last quarter with a set of very interesting speakers, generally in the field of interactive media and games. So we're kind of interested in both of those. All the talks are actually videotaped, and we have multiple thousand views on those from last quarter, so you can watch those as well. And so we continue this quarter again with a set of great speakers, and so it's my great honor to introduce the first set, and it's actually two speakers, which is unusual, and it's Yee and Nic Ducheneaut. Both have PhDs. They met when working together at Xerox PARC, then they worked for a while at Ubisoft, and then they started their own consultant company, and that's what they're going to talk about. Okay.
My name is Yee. This is Nic Ducheneaut. I'll be giving the talk, and Nic will be back here and joining me for the Q&A. Both Nic and I have been studying video games for over a decade, and we recently started our own consulting practice around game analytics. There are going to be two sections of the talk. I'm going to start by giving you a sense of our research trajectory, the kind of work that got us into the game industry. But what I really want to focus on in the talk are the surprising challenges that we've seen in terms of gaining insight from in-game analytics from a game industry perspective. Both Nic Ducheneaut and I are a mix of social scientists and data scientists, and we were both gamers before we were researchers. And we both started studying video games before the big data revolution was a thing. So in the early 2000s, I had a long-running survey project of online gamers called the Datalist Project. So over a few years, I'd surveyed over 55,000 online gamers in games like EverQuest and World of Warcraft. And I was exploring, who were the people who played these games and what did they enjoy about these games. Just as, a snippet of the kind of findings that I produced, using survey data from thousands of online gamers, I've identified a 3 high-level motivation framework among these gamers. So there are people who are motivated by achievement, different ways of gaining power in the world. There's a social prong, different ways of relating to other players in the game world, and an immersion prong, different ways of becoming a part of the story of the game world. And we validated this framework cross-culturally in EU and in China and Hong Kong. We've looked at how these factors, these motivations vary by demographics, and how they're actually connected with in-game behaviors. When someone's playing a game, how do these motivations actually connect with the behaviors they prefer? The survey work that I did actually overlapped with my graduate work here at Stanford. I worked with Jeremy Bailenson over in the comm department in his virtual reality lab. And we were interested in VR as a new platform to study human psychology. We designed many lab studies to understand how people's avatars in virtual worlds change the way that they behave. So we tend to think of avatars in games as things that we create, we customize, and we have control over. But it turns out that our avatars change the way that we behave and think. So for example, when you put someone in a more attractive avatar, they walk closer to and they share more personal information with a virtual stranger than someone who's put in an unattractive avatar. And in another study, we found that when you put someone in a slightly taller avatar, they negotiate more aggressively in the bargaining task than someone who was given a shorter avatar. Around the same time, this is circa 2005, Nic Ducheneaut was already a research scientist at the Palo Alto Research Center, Xerox PARC. And he and his colleagues started studying online games like World of Warcraft. And at that point, World of Warcraft was interesting in that it provided, apart from just playing the game, there was a scripting language in the game that allowed third parties, gamers or third-party developers, to modify the interface and to create add-ons. These were fairly simple things at first. So if you were a healer, you could have an add-on that told you which member in your party needed healing the most at this moment. So there was, some interface changes. But what Nic and his team figured out how to do was to use that scripting language to create an automated census robot. And so every hour, the robot would go in World of Warcraft and take a census snapshot of the thousands of gamers on each server and would do it on 5 different servers. And he was collecting data for about 3 months. when he brought me on as a summer intern. So what was interesting was at this point, you could only get 7 variables per character. The character name, their gender, whether they were in a group, what zone they were in, geographic area they were in the game. So fairly simple variables, but the variable that kind of caught us all by surprise was time. That we had these 7 variables, but over very long periods of time. And it allowed us to do things such as construct social networks among the gamers, the characters in the game, and see, for example, how guilds survive or don't survive over a 6-month period. What are the variables that influence virtual community survival or failure? One of the more interesting findings we found had to do with what we think of as almost parallel worlds. We were trying to understand what made World of Warcraft so popular. World of Warcraft is labeled as a massively multiplayer online game, so you'd expect that there's a lot of social activity going on, that most people are in groups and hanging out with others a great deal of time. But when we went through the data longitudinally, what we found was that most players in World of Warcraft spend the majority of their playing time alone. And we started thinking about why this might be, and we came across this notion of social ambiance. So it's kind of like a coffee shop, right? So you're at a coffee shop, and there are a lot of people milling around. There's a social atmosphere, and and if you're reading a book at a coffee shop, it feels very different to have that social ambiance around you than if you're doing it alone, say, in your own home. And what we found was that was actually a compelling experience for a lot of gamers, having a space where if you wanted to be social, you could easily find a group, find new players to do a dungeon. And if you wanted to be solitary, it's possible to play World of Warcraft from level 1 to level 100 all by yourself without ever talking and interacting with another person. So what we figured out was that World of Warcraft was really good at creating these parallel forms of play side by side with a lot of bridges. If you start off soloing and being solitary, it's very easy to shift to the social track and vice versa. And World of Warcraft doesn't penalize you for playing the game one way or the other. And this parallelism is actually true of most of the separate systems in World of Warcraft. So it encourages separate forms of play side by side without penalizing any particular preference. And it was specifically games like EverQuest and World of Warcraft that ushered in the era of big data in the game industry. Now when you play an online game, all the player interaction data has to stream across the company's server. So now the game company, has easy access to all the behavioral data that's streaming through, and they're piping that into their storage databases. Prior to this, most games that you play on your console at home without an internet connection, there's no easy way for the game company to figure out what you were doing in the game. There's no easy way for them to gather large amounts of behavioral data. But when you're playing a game online, all that data is actually part of the game. It's what makes the game work, right? So when Nick attacks a goblin, for that to be shown on my computer, on my end, that data is traveling through the game server. And so now in a game like World of Warcraft, everything you do, everything you say, and anyone you've ever talked to, all this is automatically tracked and stored in a big data warehouse somewhere. So for example, Blizzard created a website called the Armory. So here's a screenshot from the Armory. So you can search the name of any active character in the game and returns this very neatly organized spreadsheet. For every active character, there are over 3,500 behavioral variables that the website exposes to you. And all these variables are updated on a daily basis if the character was active the day before. And the variables span a wide range of activities in the game, down to the level of how many virtual hugs any character has ever given in the game. So online games suddenly became a truly unique data source from a social science perspective. At the time where Nick and I were doing this, there really was no easy way to gather behavioral data from people the way it was so easy to grab data from the Armory. And it's possible to have these really rich longitudinal behavioral profiles of millions of players at the same time. And it wasn't just self-report survey data, right? This wasn't just what people said they did or that they liked. It was what they actually did in the game. These were actual behaviors. And so it opened up new kinds of questions that we could be asking about these online spaces and the psychology of these gamers. When we were still at Park for the last 3 years, we got government funding for a project. where the question was, can you infer someone's real-world demographics, their gender, their age, their personality, just by looking at how they behave in a virtual world like Second Life or World of Warcraft? And so for the study, we recruited World of Warcraft gamers using an online survey. We asked them for their active characters in the game. And then we went to the Armory, and over a 6-month period, we generated a longitudinal behavioral profile for all of our participants. And it turned out that we could make those inferences. So for example, we found a very simple rule that could make the inference if someone was male in the real life at 95% accuracy. We found another rule in terms of personality. So people who are less conscientious in the real world are more likely to die from falling from high places in the game. And as we were thinking through this, we realized, in our papers, we started writing about the possibility of tailoring gameplay. So we had all this data that allowed us to link up demographics, personality, player motivation, and what players actually did in the game. So we thought it may be possible, in a game where you infer someone's personality and motivation by observing their gameplay and then being able to dynamically tailor the game to their preferences. So one example is if we can infer that someone has a more competitive personality, perhaps we can highlight or foreground the ranking board, the leader list in the game, so that it's easier for them to see how their personality can be expressed in the game. So it was around 2012, we'd finished this 3-year project at Park that Nic Ducheneaut and I decided to try working directly within the game industry. It was always hard getting access to game data as an outsider. World of Warcraft, the Armory data was a really unique exception within the game industry. For the most part, if you go up to game companies as a researcher and say, are you willing to share your data? They'll say no. And so we joined Ubisoft, to try to get a sense of what we could do within a game company directly. And so in 2012, we joined Ubisoft and we created the Gamer Behavior Research Group. And our role at Ubisoft was to connect the in-game data with targeted surveys of gamers to really understand why players did what they did. As you can imagine, we can't talk too specifically about most of our work at Ubisoft, but there's one talk that we gave at the Game Developers Conference last year whose content that we can talk about fairly openly. So within the game industry, when someone spends a lot of money in a free-to-play game, the game industry typically calls them whales, and this term is drawn directly from the casino industry. It's not a flattering term, and there's a broad assumption in the game industry that whales are people who are highly impulsive and hedonistic, if not outright pathological. And because of this assumption, a lot of the game mechanisms that do monetization to compel people to pay real money in these games revolve around around impulsive mechanisms. So for example, you can buy mystery boxes. You don't know exactly what you're going to get, but it could be something really, really good. So that's one. The other thing is one-time offer. So you've just hit the next level. I'm going to give you this offer. You can buy this virtual chair at 50% off, and if it's a one-time offer. If you don't buy it now, you can't ever get this low price again. So there are a lot of mechanisms that revolve around impulse control. And when we were research scientists at Ubisoft, we were working with one game, Ghost Recon Phantoms, that had a huge monetization component. We were trying to help them understand what players really wanted. And so we decided to test this assumption. Are whales, high spenders, actually impulsive and hedonistic? And so we did a segmentation of spending patterns in the game. We then we segmented those players and then sampled players in each of, high spenders, one-time spenders, people who've never spent anything in a game, and then ran a personality profiling survey on those gamers. And what we found was that it was exactly the opposite of what the game designers had assumed. Instead of being impulsive, people who spend a lot of money in Ghost Recon Phantoms, it's a first-person shooter game. It's a team-based first-person shooter game. That these players were very cool-headed, they were methodical, and they saw their payment, they saw their monetization as a long-term investment to hone their craft. And we were like, oh, that's interesting. And we took a step back and we realized, well, when you meet someone and they say they spent hours and hours and a lot of money in building up a model railroad, the typical reaction is, wow, they're really dedicated to their hobby. The typical reaction isn't, wow, they're pathologically impulsive. But in the game industry, there's this assumption that when someone spends a lot of time and a lot of money in a game, that they must be pathological. And so it was interesting when we did the study that we found that it wasn't necessarily true. And so we went back to the design team and we said, instead of designing for these mystery boxes and these one-time offers, what if we made it easier for players to compare different products in the store? And we really describe how these items can improve their mastery of the game instead. So that, in a nutshell, is the kind of work that we were doing at Ubisoft. It blended the in-game data with challenging the assumptions that game designers had, using frameworks from social psychology and personality psychology. So we were at Ubisoft for about 2.5 years, and we noticed one trend that was interesting in terms of the current state of game analytics. So there's a lot of data that's coming into these games, and the current market is oversaturated with automated black box solutions. So let me give you one good example. So a KPI is a key performance indicator, and in the game industry, these are things like daily active users, DAU, average revenue per user, ARPU, average session length. And so a KPI dashboard is a product that you can get, you plug in your data stream in a game company, and it produces these very pretty charts, collated on a web page that tells you how well you're gaming in terms of the KPIs. But the problem tends to be this. So you now have this box sitting at your office, and every once in a while, it raises a red flag and says, your game is doing poorly this week. But what it doesn't do is tell you why your game is doing poorly and what you could do instead to alleviate the problem. And so you know that there's a problem, but you don't know why. And because you don't know why, there's no easy way to solve, this problem. Predictive analytics have the same problem in the game industry. So these are machine learning algorithms that allow you to predict whether a specific player is likely to quit the game soon or likely to spend a lot of money in the game soon. We found this quote from Gama Sutra from Dmitry Nazanin. So what he said was, knowing with very high accuracy when a player will leave, I still don't have a clue why she will leave. And because the why isn't being explained, it's very difficult to figure out, well, what do you do with this player who's about to leave? What do you say to them? What's the correct message? Is intervention just going to make them leave faster? And the one thing we realized was a lot of these products try to automate analytics with a one-size-fits-all solution, but our perspective is that you really have to get your hands dirty and understand the context of the game and its players to really derive insight into why players do what they do. And that was a big reason why Nick and I decided to start our own consulting practice and have a go at this on our own and see what we can do, from the outside. And so what we've done a lot in the past 2 months, we started the company only in the beginning of this year. So what we've done in the past 2 months is to talk to as many people as we can in the game industry to really better understand the culture of game analytics and how analytics is done in different game companies. So game companies are first and foremost creative companies. People who become game designers are passionate about playing games, they're passionate about making games, and they have games in their mind that they want to create, and that's why they became game designers. So oftentimes, game designers or the studio team can feel threatened by game analysts because they feel that the game analyst is telling them how to do their job. And this can express itself in different ways. One of the game analysts that we talked to put it the most diplomatically. He said, you get varying degrees of artistic temperament to deal with no matter which company you go to. When we were at Ubisoft, we worked with a creative director, and we were trying to do a short presentation, a short workshop on standardized personality frameworks in psychology. So in psychology, the current gold standard for measuring personality is called the Big Five. These are 5 high-level factors that are understood to explain a broad variation of human differences in personality. And so we were chatting with this creative director, well, here are some of the things that we could talk about. And one of the things was he's like, whoa, Nix, before you even get to the Big Five, you need to start by convincing them that people are different in quantifiable ways, that's the level you need to start at, because that's what will take you the most time. You probably won't even get to the Big Five in your first talk. And we're like, well, why is that? And we slowly understood that some designers hold the view that humans are complex and their motivations are unquantifiable. And the reason why they hold this belief is that if everyone is complex in undefined ways, then it's okay for them to make a game that they enjoy, since there's no systematic way to do it differently. So that was one example of the kind of cultural dynamics that we were running into. But let's take one step back. Big data and analytics is still quite new in the game industry. It's really only since World of Warcraft and the big data revolution that everyone perceives their data as being a potential source of strategic insight. And so most game companies are still figuring out how do we integrate analytics, and there are very few standard practices around doing analytics in game companies. But what is universal is that analytics is the newcomer to the table at game companies. And whenever you invite someone new to give them a seat at the table and you give them a say, it always upsets existing balance of power, right? So we have to figure out, well, how much say does this newcomer actually have? How does the data flow through them? Who has access and control over the data sources? And the newcomer doesn't just change the existing balance of power, but they also change how the existing members on the team, the design team, the marketing team, how do they relate to each other now that there's a new person at the table who also has a say on how the game is being designed? And so in very real ways, in different companies, analytics upsets the status quo about who gets a say. And one thing we've heard often when we talk to analysts in game industry is that there's always internal drama around this in every game company of how the balance of power shifts and changes and how it settles. And the flavor it takes is always slightly different depending on how the power falls. So in some companies, it's the game designers who get to maintain their creative division and they get to sideline the analytics a little. In other companies, the analytics has this huge say. Anything that the data shows, they're going to implement in the game design. But unfortunately, there's a structural reason why analytics is often at the bottom of the totem pole. And it's super obvious once I say it, but it just took us some time to internalize. So the hooks that you build in a game to track game data, they're often referred to as telemetry. And telemetry is the one thing that gamers will never see in their game and has zero impact on the reviews of the game, right? No one goes onto a game review site and said, wow, this game has wonderful telemetry. And in fact, telemetry is nowhere near as important as the graphics, the level design, the music, the sound effects. In fact, it comes pretty near the bottom of the priority list. And it comes at the bottom of the priority list, not just during the development of the game, but also during the testing of the game and the patching of the game once a game comes out. So oftentimes, telemetry is the one thing that the least time is devoted to when people think about what to implement. And if something breaks during testing, it's also the last thing that's going to be fixed, right? Because it's much more important to fix the graphics, any game bugs, before you fix the telemetry. And after the game is launched and someone, an analyst downstream realizes, wait a minute, there's something wrong with how the data is being tracked, it's also not high on the priority list of it being patched in the game. So one example of this that we've heard is, for example, when you're playing a big multiplayer game where there's an online gaming component and there's a high server load, say it's the launch weekend, and there are a lot of players that are trying to log in. Telemetry is often the first thing that you bump off because it's better to lose the tracking data than to have the entire game server crash. And so often you're losing the tracking data when it's the most important to the game company. For example, the weekend right after the game launches, right? And it's due to these structural reasons within the game company and what's prioritized and what's not. And so even though a lot of game companies understand that there's a lot of potential insight you can get from the game data, culturally within the game company, it's often the thing that's often on the short list, that's on the bottom of the totem pole. But the situation gets actually a little more complicated. So the game developers, the studio team, are the people who code and decide what things to track in the game and what telemetry to implement. But they're not the ones who end up analyzing the data, right? It's the game analysts who end up analyzing the data, but the game analysts are far removed from what data is being collected in the game because they're not the frontline programmers. And because the game developers are not game analysts, it's hard for them oftentimes to figure out and understand what metrics in a game are important to track. So there's a tendency to focus on metrics that might reveal game bugs because that does impact the game developer's work. And there's also a tendency to track what's easy to track rather than what's meaningful to track for data analysis. So one example that we've seen, for example, is that it's far easier to write the code to track how often players use the dozens of gun models in a game, rather than figure out how to track, a dozen conceptually different behaviors in the game. And again, it's because there's this disconnect between who creates a telemetry and who actually analyzes the data. But it could get worse. So consider the existing tensions between the analytics and the design team. So teams with a very strong creative vision could consciously or unconsciously sabotage the analytics in a large variety of ways. They could delay implementation of the telemetry, such that it's the last thing to be implemented, that it's rushed. They could forego telemetry testing, that it's more important to test the other things before the telemetry. So the telemetry ends up being a little buggy. And so it makes it more difficult for the analyst to come up with robust insights into the game data. And it's not, so one reason why this happens, of course, is I mentioned earlier, it's the perceived threat of game analysts coming into the game studio and telling the designers how to do their jobs. But there are other parallel reasons. So for example, it also allows the design to occur without being heavily scrutinized, right? It keeps the design team isolated from outside influences. And of course, no one likes to be told that they made a mistake by someone outside of the team, by an outsider. So by guarding the data, it's one way that teams can keep their mistakes within the team, that people outside the team can't easily understand or verify the mistakes that were made. So in an odd way, it's possible to implement game analytics in a way that preserves the status quo, that the designers still have a say, while paying lip service to the analytics. It's possible to implement analytics and still preserve the existing balance of power. And I've painted this somewhat malicious picture, and I don't want you to walk away thinking it's necessarily malicious. If you're working on a piece of art, you can't have people knocking on your door and barging in every 5 minutes telling you what to do. That would drive a designer crazy, drive an artist crazy. So it's natural that design teams would want to minimize disruptions. So there are both positive and negative reasons for why the design teams may be incentivized to not share data in the appropriate ways. So I've touched on how the data is created and how the telemetry is implemented. But I want to touch now on how the data is shared after it's been collected in the big databases. So the game data doesn't just magically appear in the hands of the game analyst. There's a long chain that the data has to pass through, and as the data passes through those chains, silent errors and assumptions are always introduced. We've touched on how the game developers are the ones who decide what to track and what telemetry to implement. And it's oftentimes a separate team that's in charge of actually storing the data as it comes in. This data warehousing team makes their own decisions in terms of how often and what format this data is stored. And they often have a say in how the data how those metrics are prioritized if the server load becomes high and something has to be dropped. And once the data comes in and it's in the data warehouse, the warehousing team often pre-processes and cleans the data a little and puts it into a database that is then accessible by the data analyst. But at every step, there are these assumptions on what is being tracked and how it's being tracked. And when you're 3 layers down, oftentimes the potential problems can become quite hidden by the time the data gets to you. So one example that we heard when we were chatting with game analysts, here's one example is, it's a data analyst who requests aggregate data from the data warehousing team. He's trying to analyze, the players who joined the game during the launch week. And what the data warehousing team doesn't realize is that there's a tracking error in their data, that because of the server load, a lot of the hours in the early game were dropped the first weekend. But he aggregates and collates this data for the data analyst. So by the time it gets to the data analyst, there's no easy way for the analyst to uncover the missing data because he's only looking at the aggregate data. The oddest thing is, even with all these obstacles in the way, it's still possible for a lot of work to be done. So there's a great deal of data streaming in every minute. There's a really sophisticated data warehousing system that is storing another few hundred gigabytes of data every day. And there are these KPI dashboards on the front end that's turning all this data into very pretty charts. So when you have this system in place, even with all the problems underlying in the back end, oftentimes it produces the illusion of insight, right? That a lot is being processed and a lot is being extracted from the data, even with all these problems, because these problems can become quite hidden and silent when you're looking at it from a 50,000 feet level. So when people typically think about game analysts, and when people tend to think of how can we help game analysts, what are tools we can give them to help them do their jobs better? Oftentimes it starts from the assumption that the data that they have is good enough, and they just need a tool at the very last step to do better analyses, to make more efficient algorithms, create new machine learning algorithms that really help them understand what's going on. But the biggest lesson that we've learned is that this approach is oftentimes solving the wrong problem. So the real problem starts much further upstream. It's that if you're not collecting good data in a clean way, you won't find good insights, no matter how hard you bang on the problem with your hammer. And this problem is really, really hard to solve because it's cultural and structural rather than technical. You can't solve this problem with new software or a better statistical package or a new machine learning algorithm. But this is a spot that we're kind of in terms of the game industry and its maturity curve with game analytics, that a lot of game companies are trying to figure out, how do we get past this point? And I don't want you to walk away, especially those of you who are students, who are interested in the game industry. I don't want you to walk away thinking that the game industry is horribly dysfunctional. This is how organizations always are. There are always these internal cultural, structural balance of power issues. If you talk to your professors about the politics of peer review or the tenure process, you'll kind of get the same drama in a different flavor. And so this isn't unique to the game industry, but it was just really important for us as consultants to really understand what's going on in the game industry. That was the end of my talk. I just want to briefly mention my book, The Proteus Paradox on the Psychology of Online Games and Virtual Worlds. And Nick and I are now happy to take any questions you might have.